G'day, I'm Jared from Tyre Review, and we're at SEMA 2019, which is the big aftermarket parts show in Las Vegas in the US. And I'm standing here with Tim from Standards Testing Labs. They're from Ohio, and these are the guys that they send the tyres to for testing before they get into your hands or onto your cars. So, Tim, you want to tell us a little bit about Standards Testing Lab?
Yeah, we're a company that's been around since the late 60s. Our founder, Dick Fuller, worked for Firestone and built tire and wheel test equipment. And then when the industry went from bias ply tires to radial tires, the U.S. government said we need a place to test. So since he was Akron-based and built that equipment, he got with the government, and we started doing compliance testing for Department of Transportation. And we've been doing that ever since.
That's cool.
And then from that, it branches off with different tests, different machines, and there's a whole world of testing out there.
Yeah. So I guess, how big are you guys? How many? What machines do you have, and all that sort of stuff? So give me an idea of the breadth of what you do.
We used to tout that we were the world's largest independent testing facility, and we still are.
Wow.
Yeah, we've got over 120 test positions.
Yeah.
And each position has its own unique function for the different type of tests.
Yeah. So you'd have a few acres of machinery out there?
We've got about 10 acres in Massillon, Ohio, yeah.
How many tyres would you guys process through in a month or a year or whatever?
It all depends on the industry, what new trends are coming out, or like the tariff thing that's out now. It fluctuates, ebbs and flows like any other business.
Yeah. And most of the big guys would you'd see a lot of different brands, wouldn't you, coming through?
About every brand that's out there for OEM or aftermarket. And what we're looking at is we do overflow testing, as well as research on new brands. If someone has a new brand of tire, they want to bring it in, check the compounding, the tread patterns, the endurance and durability of the tire, they send it to us.
Yeah. And so I've heard about this UTQG thing that you guys have got over here, which is starting to come into Australia. What is that? I know it's a grading system, but can you give me a bit of background on it?
Absolutely. It's a grading system that the Department of Transportation gives to the consumer so they can make an educated purchase on their tire. It's a 3-grade system. It's called UTQG, Uniform Tire Quality Grading. It's based on tread wear, traction, and temperature. It's all a grading system. The tires will go through their paces for the different tests. They get graded per batch, and then from that batch, the tire gets a molding on the sidewall of the tire, and it also gets on a sticker on a label. So when you buy a tire and see that long sticker on the tread, that information's on that sticker.
So that's per batch, like per
brand.
Okay. Right. Yeah.
The manufacturer has their own, then each batch, and then from that, each lot of batches.
Yeah. Interesting. And you guys are a big part of that testing to actually prove the UTQG rating?
Yeah, we've got 2 different labs. One in Ohio, that's our indoor test lab, and then the one in Texas is our actual on-vehicle. On that, we do our tread wear rating. So we have vehicles and staff that drive nonstop. They'll put 1,000 miles on a vehicle in a matter of weeks. And what they do is they'll run it so long, measure the tire, do vehicle inspection, then another crew will go right back out. What they're doing is they're measuring the amount of depth and the wear on the tread and the components of the tire.
Yeah. So you're sort of doing the science-based testing inside, and then you actually go out and do testing in real-world conditions in Texas.
Yeah, right. And then the other 2 tests are the traction and the temperature. We have a traction vehicle. It's a truck that pulls an instrumented trailer, and then that has a torque cell that's in one of the positions. Drive it over a calibrated amount of water, calibrated gradient surface, whether it's asphalt or blacktop, whatnot. And then they put a braking system on it, and it locks it up, and they measure the amount of force or drag, the coefficient of friction that's on that tire.
Yeah. See, I find this stuff really interesting because basically every single tire that comes out has to go through this testing, and which means that the tire you get on your car has been tested in hundreds of different ways over many, many hours. So maybe we can even look at this tire you've got over here, which is sort of a breakdown. Can you maybe run us through the different components of the tire?
What we do is we make these tires. We have guys that do they call it a cutback.
Yeah.
And we use them for sales purposes, or we take in the courtroom and we explain to jurors the different components rather than just
Hang on, can I stop you there? For a second. So you actually get brought into the courtroom when stuff actually happens?
Yeah. Well, yeah. Wow. Yeah, that's why we have to be careful of our scientific processes, because everything we do is liable. They can be taken into court. All of our test data, all of our processes, and it's all subject to what happens in the lab.
They don't do many lawsuits over here, do they?
There's a lot of lawsuits.
So that's
That's
serious stuff.
We had an entire division dedicated just for product liability, accident reconstruction, expert witness and testimony.
Wow.
Yeah.
That's amazing.
Let's say somebody would crash their vehicle and they want to sue the manufacturer. The attorneys would hire us, and then we would replicate the tests and then take that information into the courtroom and defend. You know, tire manufacturers, they've got a lot of money for technology and innovation, and they're not about to put out a product that's defective. It's that guy that falls asleep at the wheel or dozes off, whatever, and he wrecks the car and he blames it on the tire. So we're there to defend those manufacturers.
Wow, that's amazing.
Yeah.
So you make these models just for that. Could I buy one of these?
Sure, you can buy that.
Excellent. I'll get your number afterwards because I find them quite cool. But
you can contact us on our website. I mean, we can hire that out. But one thing it helps, it's a demonstrative it's not so static like a two-dimensional photo. We can go to the jury and say, okay, in the third ply, it went from steel to fabric. So you can go 1, 2, okay, that's fabric. So you can explain in this layer where this belt edge rubber comes in, and you can start to explain the components of a tire and how they work in relation to one another.
Yeah. So do you want to step us through the components of the tire, maybe from the outside in? Is that right?
We have that much time.
Wow.
Well, let me just show you this one. I mean, you've got your bead bundle here. You've got your apex turn-ups. You've got different wedge strip rubber down here. There's about 6 or 7, depending on the tire, different types of rubber in one of these.
Yeah.
And each one has its own chemical properties. Each one has its own function.
Yeah.
It has to be able, this one might have to have more movement as it gets exercised. And this one might have to be able to dissipate heat a little bit better. This one might have to hold a little bit of heat better. So all these components are designed, and when you look at it in this format, it's not just a tire that's round and black and goes in your car. There's actually technology and innovation and intentional purpose in each one of these.
Yes.
This cord structure here has certain width, and they call it denier strength and tensile strength, and how does it marry and match with the other components, and does it function well?
Yeah.
A good example, like you drive down the highway and you see the tire strips of rubber along the belt, the road, highway, and they call them alligators. I don't know what you call them down there, but what it is, they call it parasitic failure. It's this belt edge right here, this wedge strip of gum rubber that it fatigues, or if you put a tire in a warehouse at high heat, let's say for 2 or 3 years, that becomes brittle. And then as you fatigue that and exercise that comes apart, and this belt package comes off of the carcass, and that's what you see on the road along the highway.
Full delamination.
Yeah, it just delaminates, it comes apart.
Yeah, that's amazing. Cool. So it looks like it starts off with fabric layers, and then is this steel up here?
Yeah, that's steel. You can get nylon, rayon, fiberglass. There's a couple of different types of glasses in there, and it all responds different to heat.
Yeah.
Wear, friction, traction, stuff like that. Yeah, then the steel up there, that has its own property as well. Some people use aluminum. I mean, this is brass.
It's brass. Yeah, right. That's cool. So maybe we can go across and talk about some of the machines that you use, or some of the testing theories that you use in front of the board over here.
You want to finish talking about UTQG?
Oh, hang on. Finish talking about UTQG. Sorry.
So yes, those 3 are molded into the sidewall: temperature, traction, and treadwear. Treadwear, we only tested in one place in America. It's Uvalde, Texas. That's because it has consistent climate, and our Department of Transportation has laid out a specific map. So it has all the gradient surface. You got asphalt, pavement, gravel, dirt, has all the possible, with the exception of snow, that's going to wear and abrade on this rubber. So it has the right amount of turns, stop, go, and then everything is subjected to the exact same conditions. So treadwear we talked about, traction would be with a traction trailer, with that instrumented trailer we talked about, and then temperature. So we'll take this and put it on a road wheel. Road wheel is a simulated indoor test where we'll run it up to high speeds, and then depending on the performance of the tire, whether it can tolerate that speed or not, is where it's graded: A, B, C, or D.
Yeah. Interesting.
I just said D. It's A, B, or C.
That's right. It's been a long day.
Yeah.
Cool.
So
that's fascinating. And then got a couple of the machines over here on the board. Which is your favorite testing machine?
well, I like them all. But I would have to say that the standard bulk it's called a radial fatigue. Because we test tires and wheels, it's a wonderful thing, because the knowledge we learn from testing wheels, we apply to test tires. Knowledge we know from test tires, we apply to wheel testing.
Yeah.
So each one has their own industry standard, but as far as the tires, the basic for a manufacturer to put a tire on an American highway to apply for a serial number, everyone has a DOT number. They have to meet the requirements of endurance, high speed, plunger, and measurements and labeling. So all the tires that get a labeling have to be within spec and dimension. All that's laid out and specified.
Yep.
So endurance for a passenger car, light truck type, you're looking at 34 to 47 hours of continual running with a step load. At each increment, you'll get a step increase in load until the tire can fail. Pretty easy test. If you can't meet a DOT minimum, you need to go back and start over.
So do you get many tires that actually go bang in that stage?
There are some.
Yep.
Yeah. I mean, you're looking at if the manufacturer's trying to do initial validation or just kind of do benchmark testing to see how well their tire's doing. Yeah, we see all kind of failures because they're testing. They go there, they might make a change in the compound or whatever, and then they come back, try it again. But a lot of it is validation work. All the tires that are out there on the highway, they take a batch of those tires and they do product validation just to make sure that everything's good. If they're changing supplier, changing manufacturing process, all of it gets validated again. So endurance, durability, then you get high speed. It's got some high speed numbers to it. Plunger, this is a plunger machine where
this one here?
Yeah. It's kind of hard to see. This one's a little upside down, but you've got a 3/4 inch hemispherical probe, just kind of like your thumb, and we'll push that through with a hydraulic press through the belt and body plies of the tire. That's that steel that you had seen on the model.
Yeah.
So what we're trying to do is we're trying to separate that.
Yeah.
All right, so the machine will give you a certain amount of numbers to tell you where it is before it starts to break. We apply that to a schedule provided by the Department of Transportation. If it meets the minimum, you're good to go.
So is the thumb flat or is the thumb sort of rounded?
It's hemispherical.
Okay, so it's rounded.
It's rounded off like you can see
that.
the bottom there.
Oh yes. Yeah. That's cool. And then
you're looking at wedge bead unseat. Then you're looking at bead unseat. Bead unseating is tires mounted horizontally, and then a shoe comes down and tries to force the sidewall of the tire off of the rim flange itself. We're taking measurements off of that. So if you're doing a lateral move, or you're skidding, or you're pull into a parking space and hit that little concrete bumper up there, it doesn't force the tire off the wheel. And we're looking at what value does that tire and wheel have.
So what sort of pounds of pressure are we looking at to remove to unseat a bead? Like, is there a minimum or?
Yeah, there's a minimum. You're talking around 2,000 pounds.
Yeah. So what's that? About 800 kilos for those playing along at home. Let's pick one more machine and then we'll finish up.
You choose.
This one looks interesting.
All right. This one is originally a motorcycle tire test machine. These are the two same machines.
Yeah.
What you're looking at are steer and camber inputs. You see the round ways on the bottom. That's a 15-degree input. So you're looking at when a vehicle gets set up, it has toe and camber, right, on the wheels. Well, that's what this does. And during testing, if you can this is the road wheel in the center, 67-inch drum. That rotates, tires loaded into that, and then that's what simulates the dynamic testing. You put that road wheel in, and you put cyclic steer or put camber on it, those are the inputs that are being put into the tire. That's a tire test that's designed to isolate those components you had seen in that cut down.
Yeah.
So you can focus the energies into the bead, the sidewall, the shoulder, the belt edge.
So you really put stress on that one component to see if it fails.
Yeah, you over exaggerate the test because you can't put a lifetime of cycles on that in a matter of hours just to get that kind of data.
So I guess that's my question is, and probably finish up with this one, is how long would it take for a tire? I mean, obviously it's a development process, but like a tire that's newly developed and they come to you with the first prototypes, how long do you reckon it would normally take on an average? I know it's a long piece of string question, but how long would it take on average from initial phase right the way through to a tire that's actually out to market?
Well, it takes 3 years to put a tire to market.
Really?
Oh yeah, through the development and testing, it takes.
So all the brand new tires that we're seeing here at the SEMA show in 2019, they would have been in development for at least 3 years.
Yeah, that's about the average.
Yeah.
Unless you fast track it and put something out there, but.
Yeah. You don't want to do that. No, but even to get like a UTQG rating, so a tire that you're seeing fresh first time to get a UTQG rating, how long would that take?
UTQG ratings, by the time you just do the initial testing, then you start to analyze your data and get it into the marketing. It takes a while. There's just too many pieces and components to just put it out there.
Yeah. So I guess that's the thing I find really interesting about what these guys do, is that they have to do so much testing that we never hear about. So I'm really keen to come visit you guys next year if you'll have me, and if we can work out the security protocols and privacy and all that sort of stuff. But watch this space, and thank you very much, Tim.
Sure thing.
Cheers.
Jared.
Thanks, everyone.